Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about long shot space. So let's dive deep into it. So what's the idea? Basically, idea is a yeet cannon. You're going to yeet stuff into space and how the heck it can be done? Well, here's the they're going to do it very cheaply. All the technology needed would be very cheap and there won't be any magic boom. You have to understand, while this puppy did manage to this is a research level, naval research level cannon, so to say. It did work. It did send stuff into basically beyond Kármán line around 150 kilometers, but there was an issue. It did not actually had the velocity. It had the orbital altitude, did not had the orbital velocity. The idea with this project was basically, the founder's idea is that if this works and if this proves the concept, we're gonna put a smaller solid rocket motors, and once you clear the atmosphere and once you already have enough oomph and you have cleared almost 100% of the atmosphere, you even with a very small rocket you can easily achieve orbital velocity. Mathematically that's viable, but this project kind of lost interest, and then like, okay, it did do what it's supposed to do, but and in terms of barrel technology it did work, because be mindful, it was a single boom event, so the barrel really needed to be like extra boomish. It's like I got this. So it did work, but again it required very lot of custom things, so to say. So this company is trying to do none of that, like no custom thing, no complex technology, and the acceleration would be slower comparatively to this or even to other things. So what does that mean? Well, this puppy can easily exceed 20,000 G, because remember there is just one big boom at the bottom and then you are pushing it. So that's not a comfortable scenario. Even spin launch, they are targeting let's just say 10,000+ of Gs, so brutal. And this puppy is only targeting 250 Gs. While that may sound a brutally lot for humans, that is more than good enough for stuff, lot of stuff. And again, if we actually made stuff for this, or you're hoping for this, or your spin launch is hoping for that, this is negligible in contrast, so to say. So that's the whole point. Artillery shells, spin launch, all of them are expecting much lower, higher systems. And the whole point of the amount of consumables, that should be almost free. In contrast, like that will be clear, it's like you have to put things in context. So if they're like, we're gonna consume 5 tons of hydrogen, pure hydrogen, that may sound a lot until you realize like that amount of gases, hydrogen or whatever gas you want, like liquid oxygen and nitrogen, that's like that's a breakfast for Starship consumes far more than that. Heck, its cold gas thruster will consume that much. So the actual consumable would be very, very little, and the whole system would be very cheap. Inherently, there is no complex part to it, not even this complex. Everything is simple. And the idea is, the end game is the same way they built the first prototype in their garage to show a pool noodle, basically a Nerf dart, bigger Nerf dart. They fired at Mach 1 speed, showing the idea that you can have multiple stage accelerating rather than requiring custom part and super complex stuff. You can just achieve very high speed very easily, and this worked. That got them enough money. That money was used to make the metal one, which exceeded high velocity, touched Mach 4. That got them even more budget. So the whole idea is it's going to be hyper cheap, because the structure is cheap, the propellant is cheap, everything about this is cheap, and the quick access part, it's no longer like one launch per day. This puppy is like one launch per hour can be done. So fundamentally the idea is very simple. It's just a yeet cannon. They're not even targeting to put human inside. The whole idea is a payload delivery mission. So that's the idea about it. So you have to understand, why didn't we do just yeet cannon long ago? Well, there are certain laws of physics you have to understand. There are certain law that says like you cannot just lol it. So basically, if you have a boom that is going on, unless it's a nuclear level boom, we have tried that. A manhole cover become orbital because there was a nuke going behind it. But anything other than that has some physical limitation. And let's assume that speed is x. You cannot achieve that x. You will always have x minus 10% or max minus 20%, depending on the efficiency of the design. So you have to understand, these are real world scenarios. You cannot just magically, what if we had this and that? Trust me, everybody tried, but we realized it very early on, surprisingly early on in weapons development, that there is upper limit. You cannot push beyond it. So for example, some people say caliber simply means is the projectile length multiplied by the barrel length. So 50 caliber simply means 1 is the projectile, 50, if you put it 50 times, that's the barrel length. I have no idea who came up with this. They could have just called L. It's like, hey, what's the length? 3L, 5L. Was like, can't use simple formulas, but That's the whole point. So caliber is like that. They're like, okay, longer barrel equals more velocity. What if we had even longer barrel, 60 caliber, 100 caliber? Well, you can do that, but there is a tiny feedback loop, which feedback loop is expansion. Basically, what you are having is dumping chemical energy that is expanding. But here's the volume is also expanding. The volume was like, here was the boom powder, here was your projectile, and boom. Okay, so you have very confined space and you are just pushing it. Everything is cool, everything is GG, and that's why rifle boom powders have much slower burning. You do want to give it time to expand. But here's the deal. What happens after 50% of the barrel? It's still, you're already done. The majority of the propellants are already consumed. Basically, it's burnt. So you are expanding the chamber. Consequence, the pressure drops, the temperature drops, meaning the oomph goes down. That's why there is an upper limit how much oomph you can put on the back. No matter what you do, there is an upper limit of barrel. No matter what you do, like we have tried it, tested it, we reached the point where it's like 50, 60 caliber is the upper limit. And you can have a smooth bore, you can increase the length just a little bit, but if you put too long of a barrel, instead of adding velocity, it will slow down, because as you are expanding, it's just like, the gases are like, come on, man. They're just like, I give up. And again, that's the law. Expanding gases cools down. So not only your pressure will go down, your temperature will also go down. We try to compensate. That's why rifle barrels have slow burning propellant, but that also has upper limit. And if you see naval guns, they generally have bags of boom powders, and based on distance, they put like more boom powders or less boom powder. That's the whole point of it. Now, this is the inherent geometry limitation. On top of that, like, okay, how fast can we go? Well, the upper limit would be always limited by what we classify as speed of sound. Speed of the sound of the propellant mix, basically, the gases that are going there. Because, again, what is transferring energy? It's not magnetic field, it's not photons, it's gases. So gases, what is the fastest action in a gas? It's speed of sound in that medium being the gas. So that creates what we call choke flow, because after choke flow, it cannot exceed beyond it. You can do that in rocket nozzle because you have converging and diverging. There is no diverging inside a barrel, so it's just converging. So what the hell you gonna do? Well, you have to simplify the gas. For example, if you have air, just normal air behind it, you are heating the air, you're going boom, you're only gonna achieve 331 meter per second, 300 meter per second. Carbon dioxide, majority of the products, that is 260. Heavier molecules are slower inherently. You can't bypass it unless you have nuke behind it. So carbon monoxide, same thing. Oxygen, 316. Now here's the deal. What happens if you go above in periodic table, start to go into lighter? Now we are talking. Go to helium. This puppy reaches 965. Lighter the element, the more it can bounce around, and the faster the speed of sound becomes. So helium can take you fast. But what if we go the lightest element, Dr. Manhattan level? That puppy touches almost 1300 meter per second. So that's the fastest, because that choke flow is much further compared to air, carbon dioxide, or whatever have you, or even water vapor. Water vapor only gives you 4 or 5. So that gives you a clear scientific destination. It's like, what can we do? Now, have we built it? Yes. This is how NASA builds it. So NASA is like, okay, we're going to put stuff in space, but it's going to get bombarded by micrometeorites and other paints, and yes, paint, other stuff, space junk. How would you test it? Well, you have to build a hypervelocity boom device. So this is hypervelocity boom device, or this. It looks like a laser, it's not, it's just a hypervelocity boom device. So the idea is you're going to take a normal shotgun cartridge and you're just going to put it here. Now this has a piston, and that piston is basically acting like a transformer. It's taking very high amp and very low voltage, and you're converting it into very low amp but ludicrously high voltage, which is velocity. So you boom it. Okay, it's gonna do its best job in this length of tubing. Now it's doing all its work. It's like, it's a boom happened, it's pushing it. So this combustion product is pushing this gas. What is this gas? Hydrogen. You're gonna do your best. You're gonna compress the hell out of hydrogen in this chamber. Now this chamber has a burst disc. That burst disc will burst the moment your pressure reaches the point. Basically the piston touches the whole point. It's a set. Now the moment the burst disc bursts, now the hydrogen is coupling the energy of this piston to that smaller projectile. Again, yeah, basically almost converting how a transformer converts. Same thing is happening here. At that point, that projectile can be traveling at bonkers speed or orbital velocity. That's why we call it hypervelocity boom devices. Hypervelocity. So these are light gas gun, highest projectile speed you can achieve with normal combustion. Again, hydrogen is the best. We cannot do much better than that. Again, you can improve efficiency, coupling efficiency from here to that smaller one. But this is the best we can do in terms of combustion, in terms of having something behind doing some work and getting more out of it. You can even do that with compressed air cannon. Basically, you have compressed air cannon doing here. It's going to get diluted till here, and then you can have hydrogen here. You're still going to get the same benefit. So this is the known physics of super duper hyperspeed projectile system, which we call light gas guns. So this is the physics of it. You have to simplify the gas itself. Otherwise, speed of sound will be like slow down. Okay, so what is their technology? Because while 1 kilometer per second sounds awesome, it does not equate to orbital velocity. That puppy is 8 kilometer per second, or actually you may need even more than that to push through the atmosphere. So bypassing it, they are doing multi-stage accelerator. So instead of doing one very big boom at the back, they are like, what if boom, 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 small, small boom. So benefit is the chamber from a gas point of view is never large. It's always getting more gas added to it. So it's not cooling down that much, and it's always able to exert enough oomph to actually keep accelerating. Now, what's the benefit of that? It will only give you the speed of the sound of the gas medium, but it can do that in much smaller length. Basically, instead of a barrel being 10 meters, you can do that in 2 meters. That's the whole point of multi-staging. It does not allow you to go higher speed, but does allow you to shrink the barrel length. That's why we want to do that. That's one benefit. Okay, instead of having theoretical requirement of 100 kilometer barrel length, now you can shrink it to 15 kilometer. That's the good part, multiple stages. That's why they have so many stages showing. So that gives you the why they are going with multiple stages. What about gases? They are using hydrogen. Now, idea is they're not going to go boom and that, piston compressing, nothing. It's just a very high pressure chamber that they have. These balls, I would say, they are high pressure chamber. Now that chamber has a very high pressure hydrogen gas around, let's say, 600 psi or maybe even higher, and they have a burst disk. Now they did try to look into what kind of speeds they are talking about when they need to dump, because yes, at high speed, if you look at the high speed footage, all the valves that they have or that you can normally buy, it opens like this. Basically, it's wasting a lot of energy. You need something that goes very quickly, like not in millisecond but in microsecond. They could not find anything cheaply enough that could even try to do that. So the idea was using burst disc. Burst disc is designed to be like boom. So how could they do that? Well, they built their own bus disc, etch it, and then they have high voltage electrical going into it. I have no idea why the heck they said high voltage. It would make sense for high current, because again that will melt it very quickly. But my understanding, best guess is it may have a design geometry that is causing arcing. That arcing is causing failure, and basically it's a electrically triggered blaster discs. So that burst disc goes boom, and again, because it's electrically controlled, they can be very fine-tuned. It's like the carriage is going, now go boom, it does boom, and they have narrowed it down to less than 100 microsecond, because they are very precise with that. So hydrogen is the chamber gas, burst disc with electrical firing is the puppy that does the dumping. Now, okay, all that is cool, but how the heck you achieve the speed? Well, you put a gearbox. Same way we have a gearbox in our car that can take the fixed RPM of our engine, fixed optimal RPM, and change it to whatever we need. Same thing is happening here. How they are doing is using geometry of triangles, aka trigonometry. Ta-da! And you can see. So basically they have 1:10 ratio, meaning gas is pushing like this, and they have a ramp. That ramp has 1:10 ratio. So this gets, theoretically, if you have no losses, this twing goes into this by 10. So 1 kilometer per second, this should go 10 kilometer per second. You are basically converting, almost like how sail does that in wind powered boats. You can have a boat traveling faster than the wind speed because you are utilizing geometry. It's almost like how you have a big bull gear rotating very slowly, how you can have a small driven gear that is ludicrously fast RPM. 100 RPM is the input, and the smaller one could be much higher. Same thing. They are giving so much stages, and you are clever trick geometry that allows them to achieve that speed. Now 1:10 is their calculation method, which again I do expect it to change as they get better. And again, they have built a dummy system, and yes, this is high speed footage of it. It does work, and they achieved Mach 4.2 reliably using a very small chamber, so to say. So it does work. The technology does work. Now, will it work till orbital speed? Again, we'll find out once they build the large scale one, but that's the idea. Everything about the science and the pipeline is time tested. It's done. Bursts are not a new thing, and this is almost same as like orbital balloon kind of scenario, where they know for a fact that all the balloons are single use, so they're going to recycle it. Here they are doing the same thing, because they're going to have so many burst discs. The idea is that the burst disc will be consumed. Basically, you're going to have burst disc, boom it, and then you collect all of it, melt it again, voila, new burst disc. So that makes more sense. So the idea is they should be able to achieve 8 km per second or under 15 kilometers of length. Now 15 may sound long, but we have things that are longer than that. as in like in a single line. It can be done. It's not impossible, it's just tedious. And again, they will achieve very high velocity very quickly. So this is the tech behind it. You are using hydrogen, you are using high pressure chambers as a dump medium, you are using burstics to allow you to dump that quickly, and you are using wedge shape to multiply as a gearbox, so to say, 10:1 ratio, so that in principle should allow you to achieve 8 km per second. Now, the only other company that is even trying to do something similar is spin launch. Now, in contrast to this, spin launch is far more complex and brutal technology. And brutal as in like brutal to the payload, meaning can this work? Again, nothing in physics says that this cannot work. Everything about this is a simple thing. It's just an energy calculation. However, you need a swing arm that needs dynamic balancing at ludicrously high energy forces. You must have seen athletes that they are spinning a mass, when they throw it, they do need time to like whoa. And we are talking about a human body that has evolved with dynamic balancing. That's not easy. Doing that with a fixed shaft, that bearing, again, if it's not done properly, bye the structure. That structure will fall apart instantaneously if it does not have the ability. It's gonna go. You do not want to have this level of arm spinning at orbital velocities. Yeah, if anything bad happens, it's not. Again, let that be very clear. When I'm talking about this sort of stuff, like this is a problem, it can be solved. Can it be solved cheaply? No. Can it be solved? Absolutely. Can it be solved cheaply? Hell no. Physics, engineering, economics. It's like saying, I want to build a nuclear reactor. Yeah, children do that. There is a freaking, child that did that in their bathroom. It's an easy thing to do. It's just that he could not pay the penalty of neutron radiation. You need almost 3 meters of solid concrete to stop neutron radiation. And again, stopping being generous here, because generally you're supposed to have water to chill it down a bit. And again, the water becomes radioactive. It's the same thing. Can you do it? Absolutely. Can you do it cheaply? That's the whole point. If we can do it cheaply, we do it. If we do not, it goes away like Concorde. So swing arm with dynamic balancing, it's not easy. And again, showing like we're gonna have this thick carbon fiber. I'm like, yeah, all you are showing me is big balance, nothing more than that. Big balance. And 2 vectors of g forces. That's brutal. You are spinning it, so your g forces is changing, and when you yeet it, it's brutal. It's gonna be brutal. And the electronics survived. It's like electronics are not what we send to space. We send observatory to space. What is the most common microsatellites that we are sending? Very few of them are radar repeaters. Most of them are optical systems. Does not mean it has to be optical in optical sense, or it could be optical in terms of infrared. It could be optical in terms of ultraviolet. Or it could be LiDAR. Those things are sensitive. Yeah, saying that, oh, we can make engineering. Of course you can make it. Question is, can you do it cheaply? You can be like, hey, our ticket cost is $100,000 compared to Elon Musk $10 million. Cool. It's just that your satellite cost now becomes $1 billion. It's like, nobody's going to do that. So that's why the idea of like, oh, we can make electronics that can survive that. Of course you can make it. Question is, do you want to? And again, I'm genuinely doubtful if they can have any optics surviving that. So, and again, cheaply, like really cheaply. So, and at the end, they will still need a booster to circularize the orbit and all that. So what does this mean? This simply means their capital cost and running cost would be far higher compared to this simple boom cannon. Like there is no competition. Like you are talking order of magnitude cheaper. So if this is 100x, that would be 5x maybe. So compared to spin launch, this technology has far higher chances of success compared to spin system, because again, everything in this can be done. It's just, can it be done cheaply? No. It's like saying, oh, we're gonna beat nuclear fusion. It's not possible. Why? We are shitting ourselves trying to stop 2 mega electron volts of neutron. You're talking about 14 mega electron volt of fusion system. There is no material known to man. We are building a new research lab just to figure out which material that can handle. Like, we do not have a material. We run it for a few minutes, and the tungsten shielding that you see, yeah, that falls apart. On a microscopic level, it falls apart. Yeah, so it's like, we're gonna do this. Like, you have to figure things out. So what can we expect in the future? Now here's the deal. You must have paid, there is a very big weird donor that has very deep pocket. That donor is Air Force. It's like, why? Well, here's the deal. From Air Force point of view, they're orgasming right now. Because here's the deal. It's a free weapons grade research lab for free. So right now, the whole world is going gaga over hypersonics, which again is slower than orbital. Orbital is Mach 25 plus, 25-ish, and hypersonics are Mach 5 plus. So do not confuse these two parts, but the idea is hypersonic is the new hotness. So if you have a contract to, hey, I will help you with hypersonic, take money, go away. Now, does this system has a benefits? Absolutely. Because here's the, what does Air Force needs? Air Force needs weapons, right? Missiles, stuff. Now, here's what does these things do? Well, they require a lot of R&D, and then you do mass production to reduce the cost. But here's the R&D is always ludicrously expensive. And if you're like, hey, I want a missile that travels at Mach 2, cost is like R&D cost. I'm not talking about the missile cost. R&D cost would be like, okay, let's say X. You go to them, it's like, okay, now give me a missile that can be fired from SR-71. Yeah, the R&D cost becomes stupid. So fundamentally, having this sort of, like, it looks so simple. Oh, the fighter jet is there and drops a missile. This is happening at 600 plus kilometer per hour. And again, it could be required to be done at Mach speeds. So fundamentally, having missile, how do you know that missile can control itself? How? Now you're like, okay, we're gonna build it. Yeah, you can do it, but it's expensive. Imagine you had a cannon that can fire at the target speed of Mach 5, Mach 6. What does that mean? That simply means you can test the guidance system far more cheaply. You can test all the guidance back. Basically, if 5 engineers are like, hey, I think we should do this, and let's say there are 2 design philosophies, like, oh, we can use this sort of electronic mechanism, and this, test both of them. And again, solid boosters for missiles are expensive. Solid boosters free system is cheap. It's just a dummy load. So from their point of view, like projectile development, basically how the shape should be, there are designs that are supposed to use basically ramjets or scramjets to increase the range. How would you fire it? This puppy is like, I got you, fam. You do not have to sacrifice a barrel, because again, barrels have a fixed lifespan. How many booms it can handle before it requires reworking. Let's say 1000 shot. You can waste that, or you can use this cannon, and where it's like, okay, it's just, we're gonna melt some stuff. And be mindful, titanium barrels, those puppies are expensive. Again, burst is free compared to that. So for projectile development, missile development, guidance control, wiring control, everything can be tested far more cheaply, far more quickly. You can do so much rapid iteration, and then you go to like, okay, now let's put some real research. Like from Air Force point of view, it's like, dude, why didn't we think of that? From their point of view, it's like, why didn't we think of it? It's like same how SpaceX built a Raptor 1 engine, which was 100% useless. It did not have enough thrust to do the orbital mission. Then why did they build it? They figured out everything else. How the heck we gonna move the engine? How the heck we gonna assemble the engine? What are the choking limits? How are we are limited? All that knowledge allowed Mach 2B to be a bit better. Mach 3 to be like, I got you, fam. That cannot happen if you're like, Mach 1 has to be good. It's gonna cost exponentially more, and it's gonna be useless. Ask Boeing. So that's the whole point. A research lab where it allows you to do actual real world testing in atmosphere at Mach speeds, shut up, take money. So they will succeed as a hypersonic lab without any issue. Let that be very clear. As a hypersonic test lab, they're like, shut up, take money. They will be booked. They will be booked. So, and again, you must have seen Air Force is also funding, hypersonic passenger jet. Yeah, they're not funding passenger jet. They're like, hey, please develop the hypersonic engine for free. And again, from Army's point of view, that's free. And they're like, okay, take that cruise missile. So please pay attention to the funding. So that's the whole point. Now, could it work as a space launch? No. This is me, Anupam Vipul, in 2024 saying that it will not work. Why? There is this tiny thing on Earth which we call atmosphere. Yeah, it does not like things traveling to it at orbital velocity. No, it's just like, look at rocket launches. What's the first thing that they do? They go up. Why? Orbit is like this, so why they are going like this? To clear the atmosphere. Otherwise, you will waste majority of your energy fighting the atmosphere. It's unwise. Go up, then go to orbital velocity. You are doing opposite of that. What if you have the orbital velocity and then you punch through it? Can you punch through it? Absolutely. There are ICBM interceptors that has almost 100 G of acceleration while going up from launch point. It needs heat shield from bottom up. But here's the, there's a penalty to that. When you're pushing through it, like, can you push through it? Absolutely. We had that system. It's called interceptors. It's just that penalty is too high, and space is a cost economy. What is the limiting factor of space? Cost. What do you want to bring down? Cost. It's almost same like how India had a lot of mobile phone service providers, a lot of them, like 5 to 6 of them. 5, 6 I remember, like there were 10 to 15 at some point. But the majority of them died. Why? Right now there are only 3, and there is a very good, one is a government, BSNL, one is VI, which most people are saying that most likely going to go away. Another is Jio, another is Airtel. Many companies have tried. Many companies opened it, and they did had a few years of good run, but then they perished. It happens same in every company, every ecosystem, every market, where you'll have a lot of options, and then only few will survive because of the cost economics. That's why I said physics, engineering, economics. As an engineering point of view, offering this sort of services, shut up, take money. Like, you may like, okay, let's say this service is good, so why they are not paying the big daddies to build that? Yeah, big daddies has so much overhead. The overhead cost of doing that is the whole project cost. Like, you go to Lockheed Martin, it's like, hey, Lockheed Martin, build me this stuff. They're like, yeah, the bid starts at $5 billion. They're like, bro, I can pay them $100,000, they can build this. Like, this is my pocket money, man. Take it and go. So that's why, like from a army's point of view, they are figuring it out. It's far more cost effective to try 10, 10 things, throw it at wall, and one or two will return. SpaceX is one of them that returned. Ask NASA. So it's one of those things. Atmosphere does not like 8 kilometers per second, but from an army's point of view, missile development point of view, heat shield development point of view, should not take money. So there is a bright future, but not as an orbital launch vehicle, as a simple research lab. So this was my presentation on this yeeting cannon. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.